Okay, business algebra, let's finish number 2 in this section and wrap up this chapter overall. So we're at the point where we need to test values on our rational function and plot them to get an idea of the shape. So let's plug in -3. F of -3 is 2 times -3 squared over -3 squared minus 5. That's 9, so this is 18. 9 minus 5 is 4. That reduces to 9 halves. So we have the point -3, 9 halves. So that's positive. We can still plot it though. -3, 9 halves is 4.5. So I'm plotting it right here. Okay, -1. It's 2 times -1 squared over -1 squared minus 4. I don't know why I did minus 5. Should have been minus 4. This was 18 over 5 instead, which doesn't reduce. 18 over 5 is a different number. It's a little bit below 4. My apologies. Writing the wrong thing. So this is now f of -1 is 2 over 1 minus 4 is -3. So we have the point -1, -2/3. Okay, so -1, -2/3 is a negative number. It's about here. F of 1 is going to be the same because all of our x's are squared. 2 times 1 squared over 1 squared minus 4 is 2 over 3, -3. So we have the point 1, -2/3. So the same thing on the opposite side, also still negative. And lastly, f of 3. 2 times 3 squared over 3 squared minus 4 is again 18 over 5. So we have the point 3, 18 over 5. So same thing on the right side. 3 and 3.6. Okay, so let's talk about what's happening here. Both of these numbers are on the left side. Every number, it looks like approaching the -2, I have to be going up because I can't go down, otherwise I would cross 0. And I need to be going to the left. There's no guarantee I stay above the asymptote, but I think it should stay above the asymptote. It could technically cross under as long as it stayed above 0 and come up from underneath. But I think it stays above. On the right side, it's the mirror image. It's coming down and going out here. Because we know it's positive. Now down here, again, towards the vertical asymptotes, it's got to be going either straight up or straight down. These can't go up because we have a 0 here, but on both sides of the 0, the values were negative. So they have to be going down on both sides. So it creates this look of like a downward facing parabola in the middle of the rational. I like to refer to this shape, the red portion. It's like one of those dogs with the really droopy faces, like the droopy ears covering the eyes and the really droopy mouth. That's what it kind of looks like to me. But this is what a rational function with 2 asymptotes can look like. They can look rather interesting. You just got to be careful with your numbers, but they are interesting looking. So now let's look at one more problem, a word problem, a business application, and see what happens. Okay, so in many situations involving environmental pollution, much of the pollutant can be removed at an inexpensive rate, but to fully purify those last few parts can be expensive. So to get like 99% of the waste out of something is sometimes not that hard with filters. To get it 100% pure would be a lot harder because of how small things are. Usually it's not considered that efficient, which is why your drink water is usually allowed to have a certain number of parts per million of certain chemicals. There's such a small amount that it usually doesn't affect anyone. Cost as a function of the percentage of pollutant removed from the environment can be calculated for various percentages. So rational functions are typically used to model this type of cost-benefit function. So suppose the cost-benefit is given by f of x equals 18x divided by 106 minus x, where f of x is in thousands of dollars and x is the percent of a pollutant removed from its environment. We can calculate how much it would take to remove 100% of this pollutant by simply plugging in 100. So when you plug in 100, you get 1800 divided by 6, which is 300. Now they said this cost is thousands of dollars. So to remove 100% of a pollutant, it costs $300,000. We could plug in 95 and 90 to find that the costs are $155,000 and $100,000 respectively. This gives you the idea. To remove 90% of the pollutant cost 1/3 to remove the last 10% and get to 100,000. So there are similar functions as well. That's not an actual problem, it's just an example. There are other types of functions called product exchange functions. And these usually happen when you have one factory producing two different goods. And the amount of goods you can produce of one is inversely proportional to the other. So like if you're a factory producing socks and underwear, the more resources you put into producing socks, the less underwear you get to produce. So let's look at the product exchange function for Fruits of the Earth winery for red wine and white wine. In number of cases is y equals 15,000 minus 75x over 1200 plus x. Find the maximum amount of each type that can be produced and use it to roughly sketch a graph. Okay, so if you're maximizing your production of one, that means you're not producing any of the other, and vice versa. So to find out when we're producing none of y, we just set y equal to 0. And of course, which part of the fraction determines when that's 0? The numerator. So 0 equals 15,000 minus 75x, which means 75x equals 15,000. We divide by 75. This should be 200. So you could produce 200 cases of red wine if you produce 0 cases of white wine. Question is, what happens if x were 0? If you produced no red wine, how much white wine could you produce? And that's just plugging in x. Y is 15,000 minus 75 times 0 over 1200 plus 0. That's just 15,000 divided by 1200, which reduces to 150 over 12, which can be further reduced to 75 over 6, or 25 over 2, which means y would be 25 over 2, or 12.5 cases. Now they said use it to sketch roughly the shape of the function. So let's look at what this is going to look like. We know that if x is 0, y is 25 over 2. You know, x is 200 and y is 0. Now you might be thinking, okay, I just draw a line between those 2 points. But remember, this is irrational. So we know the only asymptote would have been way over at negative 1200. So this should be roughly curving downward. That would be the idea, in my opinion. It should be curving downward because, again, this is like a snapshot of a rational function, the shape of our previous graphs. So that's what I would say it would roughly look like overall. And that's the end of 3.6.